So 1.2 is fractions. There's a couple of key pieces of advice I'll give you, like for each operation. But first and foremost, we need to just talk about mixed numbers versus improper fractions. So a mixed number looks like this, 3 2/5, and this is exactly equivalent to the improper fraction 17/5. Each has their own uses, okay? 3 2/5 is useful in the real world. So this is useful in the real world for understanding value. And what I mean is like, okay, so let's say you were talking about how much money you had in your bank account or how much pizza you ate. You would say, I ate, just an example, 3 1/4 pizzas, right? People go, oh wow, you ate more than 3 pizzas. That's a lot of pizzas, right? Or you would say, versus, I ate 13 quarter pizzas, right? You wouldn't say that, right? 3 1/4, yeah, 13 quarter pizzas. No one says that, right? Whereas over here, this is useful for math, right? We use this in any and all operations that we do with math, and it will become very apparent why. But I mean, for example, if your bank account, you say, how much money do I have in my bank account? And they were like, you have 10,532 sevens. You're like, what the hell is that? You know, whereas it'd be much more useful if they're like, you have, you know, $2,300 and this makes sense. That's much more useful to have the whole number, and then I don't really care about how many pennies are in my bank account, right? Whereas if they just gave you a giant fraction, you're like, wow, I hope that's a big number. Right? Improper fractions are way more useful for math because of that whole addition subtraction making life suck, right? If I said, what's 3 1/2 times 4 1/5, right? If you turn it into mixed numbers, or not mixed numbers, improper fractions, that's a really easy problem. But if you do it like this, 3 1/2 is literally 3 plus 1/2 times 4 plus 1/5, and so actually both of these are a binomial. So if you want to do this and get it correct, you have to FOIL this and say, okay, this times this, 3 times 1/5, plus 1/2 times 4, plus 1/2 times 1/5, then you have to find a common denominator between every single one of those and add them all together, those 4 different things, and that would suck, that's a nightmare. So we don't ever do any math operations with these. Okay, the one exception is if it's already a common denominator, it's just like, what's 3 1/2 plus 4 1/2? I mean, okay, you can add that together because it's already a common denominator. 3 plus 4 is 7, 1/2 plus 1/2. But you get into trouble then. If you're like, okay, well what's, 1 1/6, or let's say even like 5 1/6 minus 3 2/6. Then you're like, okay, 5 minus 3 is 2, and 1/6 minus 2/6 is -6. Like what's 2 and -6, right? So then you have to borrow, and you're like, well that's like 1 5/6, but that's a really weird way to write it. So that's why we get into trouble. So anytime we do any math, we use improper fractions. So the first step for everything is turn everything into an improper fraction. In case you were wondering what a proper fraction is, a proper fraction just means the top number is smaller. So a proper fraction would be something like 3 eighths, just where the top is smaller. Alright, so I'll give you a general strategy. I'm very much a big picture guy, so for me it's much more useful to figure out what's the big idea here and then deal with the details later. So general plan, general steps. For all fractions problems, first thing you do, turn all mixed numbers into improper fractions. Okay, that's the first step. Then 2 is do the arithmetic. Okay, that's a big shortcut there. Just do all the math. Okay, that means plus, minus, divide, multiply. No one ever uses x for multiply, but whatever. Okay, so do the arithmetic, and the last step is reduce / simplify. Mean the same thing. So the reason I give you those general steps is always your first step is turn all the mixed numbers into improper fractions, and always your last step, always, is to reduce. Okay, and now we're gonna talk about that middle step of like, do the arithmetic. We'll take, no, we're gonna take a break at once. We'll do some multiplication step. All right. So I didn't tell you how to turn a mixed number into an improper fraction, but I like letting you guys try before I teach you that. Okay. So, the first one is the easiest, multiplication. Okay, how do you multiply something like 3/5 times 2/7? It's a quick example. I start with this one because it's the easiest.
Get them over a common denominator?
That's only with addition and subtraction.
Oh, yeah.
Cross multiply.
What interesting factoid.
Cross multiply.
Yeah.
7
Straight across. All right, this is good. You guys got some learning. It's okay. But if you did make a common denominator, still totally get the right answer. Just way bigger numbers that you would have to reduce more. So it's not wrong to get a common denominator. It's just extra work you can keep. Okay. So this is just the same as 3 times 2 over 5 times 7. You just multiply the tops together. You just multiply the bottoms together. Multiplication of fractions is the easiest of all the operations. Division is only one step harder. So this is 6 over 35. We could check if we could reduce it, but we know we can't because these are both prime numbers, these are both prime numbers. There's no factoring. Yeah?
And when does that actually fall into like the cross multiplication, or is that just a myth type thing?
Yeah. So cross multiplication is something that I have this love-hate relationship with. I do it all the time, but I hate the term because then people get cross multiply and cross cancel and cross product, and all these things are very similar, totally mixed up, and use them totally wrong. But yeah, and that's going to be the next thing we talk about. So you just multiply the tops. I'm not big on vocabularies. I try and write in plain English. So multiply the tops and multiply the bottoms. Okay. And so yeah, second example is, what if we have something like 100 over 33 times 11 over 500? Okay, well you don't want to multiply those out and figure out how those cancel, so yeah, so you can cross cancel. And the thing I want you to be careful about is with multiplication only with multiplication. With multiplication only. I say that over and over because that's going to be a source of error. But with multiplication only, you can cancel anything on top with anything on bottom. Okay. So, for this one, I could, and I'll use a different color here, I could say, okay, I can divide 100 into both of these, so I get 5 and 1. I could divide 11 into both of these and get 1 and 3. So really, this is the same thing as 1/3 times 1/5. So it's 1 over 3 times 5, or 1 times 1. So it's 1 over 15. But absolutely, you can only ever cancel when you have multiplication. Never with division, never with adding, never with subtraction. Okay? Alright, division's almost exactly the same, because again, as we were talking about earlier, multiplication and division are the exact same thing. So if we want to look at division, there's one step. Right? What's the one step when we have division? Again, I'll use all prime numbers for the first one. There's no canceling. So 3/5 divided by 11/7. So one step.
Yeah.
So it's,
Invert, flip it.
so flip or invert the
Reciprocal.
the second one, the reciprocal of the second one. It's the same as when I write like 5 minus 2 minus -3. these signs only affect the things after them, right? This 5 doesn't care at all whether it's a minus, divide, plus, whatever sign's next to it. That doesn't affect the 5. The 5 is the starting value. So you would never, ever, ever flip the 3/5. You start with 3/5 and then do this. So yeah, you flip second fraction, and switch the sign to multiply. And so often in math, what's gonna happen is we're gonna learn something like multiplication. You've had a whole 30 seconds to digest it. And then we say, okay, so now here's one additional step, which is flip the second fraction and switch the sign, multiplication. And then, I'm gonna say then just do multiplication. That's assumed you have past things mastered. And that's why it's important you do the homework today and come in tomorrow knowing it, or at least having good questions. Because tomorrow, I was like, and then you deal with the fractions. And then you do order of operations, right? And it's assumed that things in the past are known. And that doesn't mean I assume every one of you is an expert, but I assume every one of you has put forth some effort, tried it, and has at least stumbled and learned from some mistakes. So it's important. Anyways, so going on, this is 3/5 times 7/11. And now it's just multiply the tops, multiply the bottoms. If there was canceling, great. These are all prime numbers. So it's 21/55. Perfect. Okay, we'll just do addition, subtraction, and then take a break. And when you come back in, I'm gonna have some problems on the board, and you guys could be working on them. These will be actual homework problems, odd numbers from your book, and we'll go over them together. Okay, I'm gonna write addition and subtraction together because they're the same thing. Right, what's the one idea when you do addition and subtraction? Common denominator. Well, addition and subtraction of regular numbers is left, right, so it's a big picture, yeah. But when you have something like this, plus something like this, you get common denominator. Okay? Real simple example. Okay? So, let's think. Is it Joseph?
Yes.
Joseph? Okay, so Joseph, if I have 3 apples and 5 bananas, how many do I have?
They're different items.
Yeah, so how many do I have?
We have a grand total of 8.
8 what?
Exactly. So you have actually 3A plus 5Y.
Yeah, 8 what? Right, what do I have? I have 8 something.
Fruit.
Why do I have 8 fruit?
Mixed fruit.
Because that's what they have. I say 8 fruit because that's what they have
Common.
in common, right? So that's the same reason when here, I say what's 1/3 plus 1/5, we'd have to figure out how many 15ths is that one and how many 15ths is it. Oh, now that we're talking about in common 15ths, we can have together. Same thing with apples and bananas. You can't say 3 apples plus 5 bananas is 8 bananas, or 8 apples, or 8 banapples, right? You need to find out what they have in common, and say, okay, so in common, I have 3 fruit and 5 fruit, now I can talk about putting them together, right? It's a simple real world example. So, find a common denominator. Change the fractions to have this denominator. And then secondly, add the tops only. Not changing the denominator. Alright, so common denominator here is 15. So I multiply top and bottom by 5. So I'm not actually changing the size of this fraction, the value of this fraction. It's still absolutely 1/3. But now I'm writing 1/3 as 5/15. 5/15. And that's the reason I want every answer on every test, on every problem reduced, is because there's an infinite number of ways to write 1/3. I could write it as 100 over 300. I could write it as pi over 3 pi. I could write it as anything over 3 times that thing, right? So rather than getting 30 different answers on the test, I have everybody reduce it, and that way everybody writes 1/3. So when we multiply by 5 and 5, we get exactly 1/3, but written in terms of 15ths. This one we multiply by 3 and by 3, and so we get plus 3/15. And now that we have a common denominator, we add these together, where the 15th is just the size. So I've got 5 of them, plus 3 of them, which is a total of 8 of them. We don't change that common denominator. We wouldn't say 15 plus 15 is 30, because that's just the size. This is the number of slices. This is the size of the wedge. Okay? All right, so that's a good place to take a break. Whoops.